Deep in 65-million-year-old rock, scientists found microscopic spheres of metal that perfectly match modern nuclear fallout. We have always believed we were the first civilization on Earth. We were wrong. Deep beneath our feet, buried within layers of rock that have slept undisturbed for 65 million years, geologists have unearthed an anomaly that defies our entire understanding of history. They are microscopic spheres, perfect in their form, forged from rare metals. They are scattered across the globe in a thin, undeniable stratum, a fingerprint that mirrors with chilling precision the fallout patterns from modern nuclear testing. But these spheres predate human civilization, predate the very concept of humanity by an impossible margin. We have always believed we were first. The first species to master fire, the first to melt metals, the first to burn fossil fuels and fundamentally alter the chemistry of our planet's atmosphere. The first to split the atom and unleash a power that could write our own eulogy in the stone. But what if we were wrong? What if the long, silent history of our world has hosted other advanced civilizations, their triumphs and tragedies so profound that they reshaped the planet only for the vast grinding engine of geological time to erase every trace of their existence? Today, we embark on a journey into the deep past, a forensic investigation of Earth itself. We will explore the faint, ghostly signatures of vanished technologies, examine the catastrophic punctuation marks of mass extinctions, and ask why the fossil record, our grand chronicle of life, contains such enormous unexplained gaps. Prepare yourselves. We are about to read the lost chapters of Earth's story. The story begins not with a cataclysm, but with a quiet observation in the sun-drenched hills of Italy. In 1980, the geologist Walter Alvarez was meticulously examining a rock outcrop near the town of Gubbio. He was tracing the great story of the dinosaurs written in the limestone cliffs that rose from the earth like the pages of a stone book. His finger, a human instrument touching a non-human timescale, followed the layers of time moving upward through the Cretaceous period, a world teeming with a dynasty of colossal life that had reigned for over 150 million years. Then he reached a boundary, a single thin band of clay no thicker than his thumb, a stark gray line separating the age of reptiles from the dawning age of mammals that followed. Below this line, the rock was rich with the fossilized shells of countless microscopic sea creatures called foraminifera. Above it, they were gone. It was a tombstone layer, a stark, silent testament to a planetary catastrophe of unimaginable scale. Intrigued by this definitive end, Alvarez and his father, the Nobel laureate physicist Luis Alvarez, posed a simple question: how long did it take for this extinction event to unfold? To answer this, they needed a clock. They chose the element iridium. Iridium is exceptionally rare in Earth's crust, but it falls to the surface as a constant, gentle rain of cosmic dust from meteorites, vaporizing in the upper atmosphere. By measuring its concentration in the clay, they believed they could calculate how many years had passed while that layer was being deposited. The samples were sent to the lab. The results that came back were not just surprising, they were impossible. The thin clay band, the line between worlds, contained levels of iridium 30 times higher than any surrounding rock layer. This was no gentle rain of cosmic dust. This was a deluge. A storm of extraterrestrial metal had saturated the entire planet in a single moment of geological time. Where could such an extraordinary amount of this rare element have possibly come from? There was only one plausible source. Iridium is abundant in asteroids. The implication was as spectacular as it was terrifying. The team had not found a clock measuring a slow decline. They had found the chemical ghost of an execution. The thin layer of clay was the settled dust from a single horrific day 65 million years ago, when a 6-mile-wide mountain of rock and ice, traveling 30 times faster than a rifle bullet, struck the Earth and ended the age of the dinosaurs. The Iridium spike became the smoking gun, the definitive proof of the impact that rewrote the book of life. But as the scientific community absorbed this revolutionary discovery, and as the dust settled on one of history's greatest detective stories, a more subtle and troubling question began to surface, a question that echoed the anomalies found in those ancient metallic spheres. If a single catastrophic event, a mere moment in geological time, could leave such a clear and persistent signature after 65 million years of erosion, volcanism, and tectonic shifting, what kind of signature would an advanced technological civilization, one that thrived for thousands or even tens of thousands of years, leave behind? And more importantly, after the deep grinding of millions of years, would we even recognize it for what it was? That lingering question, born from a thin layer of Italian clay, found its voice in a concept so provocative it bordered on science fiction, yet so rigorously logical it demanded serious consideration from the scientific community. Coined by climatologist Gavin Schmidt of NASA and astrophysicist Adam Frank of the University of Rochester, it was given a playfully memorable name, the Silurian Hypothesis, a respectful nod to an ancient intelligent reptilian species from the classic science fiction series Doctor Who. The hypothesis doesn't claim that such civilizations existed. It is more subtle and more scientifically profound. It poses a razor-sharp question: if an industrial civilization had existed on Earth millions of years before our own, what specific measurable traces would it have left behind in the geological record? Could we find them? And if we did, would we mistake them for purely natural phenomena? This idea forces us to confront the dizzying, almost incomprehensible scale of deep time, a concept our minds evolved to navigate the cycles of days and seasons can barely contain. The Earth is 4.5 billion years old. If our entire industrial civilization, from the first belching steam engines of the 18th century to the global network of the 21st, were to last for 10,000 years and then vanish completely, that entire span of achievement and hubris would represent just 2/10,000ths of 1% of Earth's history. Searching for direct evidence of such a brief, fleeting epoch would be like trying to find a single specific page torn from a book in a library that contains 4 million volumes. Our cities would crumble to dust. Our monuments would erode into nameless hills. Our metals would oxidize and leach back into the stone. In a few million years, the relentless grinding engine of geology, subduction, volcanism, erosion would pulverize almost every direct artifact of our existence into nothingness. But not every trace would be lost. An industrial civilization, regardless of its specific technology, is a planetary-scale force. It must consume vast amounts of energy. It must alter its environment. It must produce waste. These activities leave behind indirect but far more enduring signatures. They change the chemical composition of the atmosphere, alter the isotope ratios in sediments, and leave behind molecular fossils, strange, unnatural compounds that become a permanent part of the geological record, preserved in layers of rock in the ancient air, trapped within polar ice cores, and in the cold, dark stillness of the deep ocean floor. The challenge is one of recognition. We are intimately familiar with the signatures of our own industrial age because we are creating them at this very moment. We pump carbon dioxide into the atmosphere, a change that will leave an isotopic scar for millions of years. We have scattered synthetic polymers, plastics across the globe from pole to pole, creating a new, permanent geological stratum. We have created radioactive isotopes from nuclear testing that will scream their artificial origin for tens of thousands of years. Future geologists millions of years from now would have no trouble identifying the Anthropocene, the age of humans. But what if a previous civilization used different technologies? What if they harnessed geothermal energy on a massive scale, leaving a thermal anomaly but no carbon signature? What if they developed perfectly biodegradable materials far superior to our persistent plastics? What if their primary industrial pollutant was a complex atmospheric gas that we have not yet learned to look for? Their industrial fingerprints might be hiding in plain sight, logged in our geological data as inexplicable anomalies dismissed as curious but ultimately natural events. The Iridium layer at Gubbio proved that the Earth is a faithful archivist. If the planet can preserve the chemical ghost of a single day, an asteroid struck it surely can and should preserve the traces of a civilization that might have thrived for millennia. With this new and unsettling perspective, scientists began to re-examine the geological record, searching not for the fossilized bones of ancient beings, but for the chemical and isotopic ghosts of their industries. What they are beginning to find challenges our most fundamental assumption that the story of intelligence on Earth begins with us. To truly grasp the challenge posed by the Silurian Hypothesis, one must perform a difficult mental exercise, a journey not across the familiar dimensions of space, but down into the abyssal depths of time. We must learn to think on a geological scale. Imagine, if you will, the entire 4.5 billion year history of our planet compressed into a single massive library. This is no ordinary building. It is a colossal, almost infinite structure containing 4.5 million books, each thick volume representing 1,000 years of planetary history. Within this library of ages, the complete story of human civilization, from the earliest cities of Sumer in Mesopotamia to the rockets that now breach our atmosphere, would be contained within the last 10 books on the final shelf of the final aisle. The entirety of our recorded history, every empire risen and fallen, every war fought, every profound discovery made, would fit on the last few pages of the very last book. And our industrial age, the brief period in which we have been actively and measurably changing the planet's chemistry, would be but a single hastily scribbled sentence at the bottom of the final page. Now, let us imagine a civilization that rose to prominence 100 million years ago. Let us grant them a glorious existence, a technological golden age that spanned a full 50,000 years. Their story in this immense library would be represented by just 50 books. After 100 million years of relentless geological reprocessing of continents, drifting and colliding of mountains rising, and being ground down to sand of seabeds, being subducted into the molten mantle, only to be reborn as volcanic islands, most of those 50 books would have been burned, shredded, or hopelessly corrupted into unrecognizability. Their cities built of materials not so different from our own concrete and steel would be gone without a trace. Their tools of metal would have long since oxidized, leaving behind perhaps a faint reddish stain in a layer of rock. Their very bones would have been crushed, dissolved, or fossilized so rarely that the odds of one of us finding a single fragment would be astronomically small. The direct evidence, the artifacts of their existence, would be lost to the great geological eraser. But not the indirect evidence. An industrial civilization is a force of nature. Its existence would have been written not just in the books of its own time, but as footnotes and chemical annotations in the millions of books that came after. Its large-scale energy consumption would have changed the composition of the atmosphere, and that change would be recorded in the chemical makeup of rocks and in the tiny, perfect bubbles of ancient air trapped in fossilized amber and polar ice. Its industrial waste, its synthetic materials and unusual chemical compounds would have been scattered across the globe, settling into sediment layers that would eventually become stone, waiting to be read. These are the signatures we must look for. They are not the pristine, well-preserved books detailing the history of the civilization itself, but the faint chemical echoes that whisper of their presence across a gulf of time we can barely imagine. The search then is not for a needle in a haystack. It is for the lingering magnetic field of a needle that rusted away 100 million years ago in a haystack that has since been burned, buried, and turned into solid rock. The task is monumental, perhaps even impossible. But the iridium layer taught us a vital lesson. Earth keeps its records with meticulous care. The question is whether we are clever enough to read them. Earth's fossil record should be the ultimate chronicle of life, a complete and unabridged story of evolution, from the first simple single-celled organism to the complex, thriving biosphere of today. Instead, it reads like a magnificent, priceless book from which most of the pages have been violently ripped out. What remains are tantalizing fragments, isolated chapters that hint at a grander narrative we can no longer read. Paleontologists refer to these missing sections as gaps, a sterile academic word that fails to capture their staggering magnitude and their profound, disquieting mystery. These are not mere omissions. They are vast, silent abysses in the story of life periods where evolution seems to take impossible revolutionary leaps and entire ecosystems vanish and reappear without a clear explanation. The traditional explanations for these gaps are sensible and undoubtedly true in part. They point to the inherent fragility and randomness of the fossilization process, a phenomenon known as preservation bias. Soft-bodied organisms like jellyfish or worms, which likely dominated many ancient ecosystems, rarely fossilize, leaving their evolutionary history almost entirely blank. The environment is also a ruthless editor of this stone-bound book. An organism that dies in an anoxic swamp, where it is quickly buried in sediment away from oxygen and scavengers, has a far greater chance of being preserved than one that dies on an open, sun-baked plain. These factors certainly contribute to the incomplete record, ensuring that only a tiny fraction of 1% of all life that has ever existed is preserved for us to find. However, some of the gaps in the fossil record seem too systematic, too precisely timed, and too fundamentally transformative to be the result of random preservation failures alone. They are not just missing pages. They seem to be entire sections where the very plot of life takes a sudden, inexplicable turn. Crucially, they often coincide with dramatic planet-wide changes in atmospheric composition, ocean chemistry, and global climate patterns. Events that suggest something far more powerful and coordinated than normal evolutionary processes was at play. We are forced by the evidence itself to consider a disquieting alternative. What if some of these vast silent gaps are not just periods of poor fossil preservation? What if they are the overwritten chapters of Earth's history, the geological scars left by the rise and fall of previous technological civilizations? Their industrial activities could have altered the environment so drastically, polluting the oceans, changing the climate, filling the air with toxins that most existing species were driven to extinction, creating a sudden and deep gap in the fossil record. And the subsequent rapid emergence of new life forms, which we see after many of these gaps, might not be a miraculous evolutionary burst. It could be the combination of life's incredible resilience in the face of catastrophe, a rapid radiation into the newly vacant ecological niches, and perhaps, just perhaps, the direct evidence of genetic manipulation by advanced beings cleaning up their environment or engineering a new biosphere more to their liking. From this perspective, the gaps are not a record of what is missing from history. They may be a record of what was erased. Among the many missing chapters in Earth's history, none is more profound, more famous, or more fiercely debated than the Cambrian explosion. Occurring roughly 540 million years ago, this event represents nothing less than a biological Big Bang, a moment of unparalleled creation that forever changed the character of life on our world. For 3 billion years, prior life on Earth had been a relatively simple, even monotonous affair. The planet was ruled by single-celled organisms like bacteria and algae, and later by the enigmatic soft-bodied Ediacaran biota, strange quilted life forms that left behind faint impressions in ancient seabeds. The fossil record of this vast Precambrian expanse is sparse, simple, and slow-moving. Then, in the geological blink of an eye, a period of perhaps only 10 to 20 million years, the Book of Life is violently and spectacularly rewritten. Suddenly, the oceans teem with an astonishing diversity of complex multicellular animals. Creatures with hard exoskeletons, jointed limbs, compound eyes, and sophisticated symmetrical body plans appear as if from nowhere. The fossil beds of sites like the Burgess Shale in Canada reveal a menagerie of bizarre and wonderful creatures. Trilobites with their intricate armored shells, Anomalous, the formidable meter-long apex predator of its day, and the surreal five-eyed Opabinia with its long, grasping proboscis. All emerge fully formed with no clear ancestors in the preceding rocks. The fundamental architectural plans, the phyla for nearly every major animal group alive today, were established during this brief, explosive window of creativity. This is not evolution, as Charles Darwin originally envisioned it, a slow, stately, gradual process of incremental change. This is a revolution. The Cambrian explosion appears in the fossil record as though someone threw a master switch, instantly illuminating a world of breathtaking biological complexity. Traditional evolutionary theory struggles to account for this sudden high-speed leap. Where are the intermediaries? Where are the transitional fossils that should show the gradual development of the first eye, the first shell, the first articulated leg? The fossil record leading up to the Cambrian is almost entirely silent on the matter. It offers no clear chain of ancestry, no satisfying prequel to this biological blockbuster. Explanations have, of course, been proposed. A significant rise in atmospheric oxygen may have provided the metabolic fuel for larger, more active bodies. The evolution of the first true predators could have sparked a rapid evolutionary arms race, favoring the development of hard shells for defense and sharp claws for attack. Changes in ocean chemistry might have made it easier for organisms to build skeletons from available minerals. While these factors undoubtedly played a crucial role, they do not fully resolve the central mystery, the sheer speed and coordinated nature of the event. The nearly simultaneous appearance of so many complex and disparate body plans remains one of the greatest unsolved puzzles in all of paleontology. It is within this profound enigma, this apparent miracle of creation, that the Silurian hypothesis finds fertile ground for speculation. Could this biological revolution have been influenced or even caused by something other than purely natural processes? Could the dramatic environmental changes that preceded the Cambrian, the very shifts in oxygen and ocean chemistry that are used to explain the event, have been the result of planetary-scale engineering by a civilization long vanished? Perhaps the explosion of life was in fact a recovery, a rapid refilling of ecological niches left vacant by a technologically induced extinction event that wiped the planetary slate clean. The new life forms might have been the beneficiaries of a newly terraformed world. This is, of course, wild speculation. But the Cambrian explosion serves as a powerful and humbling reminder that Earth's history is not a simple, linear story. It is a tale punctuated by dramatic, planet-altering events, whose ultimate causes remain shrouded in the mists of deep time. 2 billion years before the dinosaurs, long before the first complex cells emerged from the primordial soup, Earth was an alien world unrecognizable to our modern eyes. The sky was not blue, but a pale, hazy orange. The oceans were not clear, but a murky green rich in dissolved iron. And the atmosphere was a toxic cocktail of methane, nitrogen, and carbon dioxide, a blanket almost entirely devoid of the free oxygen that is the very breath of our life. The planet's dominant life forms were simple, single-celled anaerobes organisms for whom oxygen was not a gift, but a deadly corrosive poison. They had ruled the world in quiet stability for over 1 billion years. Then something happened that would fundamentally and permanently transform the planet. In a geological moment, the chemistry of the entire world was rewritten. This event is known as the Great Oxygenation Event, and it was without question the single greatest pollution crisis in Earth's long history. Over a relatively short period, oxygen levels in the atmosphere began to rise dramatically. This newly abundant gas, the waste product of a revolutionary new type of bacteria called cyanobacteria that had mastered the art of photosynthesis, was catastrophic for the incumbent life. For the anaerobic organisms that had dominated the world for an eon, it was an apocalypse. The oxygen-rich atmosphere poisoned them on a massive planetary scale, triggering one of the first and largest mass extinctions on record. But from this planetary poisoning, a new world was born. The rise of oxygen enabled the evolution of aerobic respiration, a far more efficient method of generating energy, which in turn paved the way for the emergence of larger, more complex life forms, including eventually us. Scientists attribute this profound transformation to the brilliant biological innovation of cyanobacteria. It is a compelling and elegant natural explanation. But the timing and the scale of the event, when viewed through the lens of the Silurian Hypothesis, raise unsettling questions. The transition was not smooth or gradual. Geochemical records show that the oxygen increase was remarkably sudden and systematic. It follows a pattern that, if seen in a more recent geological context, might be interpreted as a massive coordinated effort in planetary engineering. Let us engage in a thought experiment. Imagine a hypothetical ancient civilization, perhaps not even native to this world, seeking to make the planet habitable for their own oxygen-breathing biology. Their primary goal would be to eliminate the thick, methane-rich atmosphere and replace it with one dominated by nitrogen and oxygen. How would they achieve such a monumental task? They might deploy a purpose-engineered microorganism, a self-replicating biological machine designed for the sole purpose of pumping out vast quantities of oxygen. The result of such a terraforming project would look exactly like the Great Oxygenation Event, a sudden dramatic spike in atmospheric oxygen, a mass extinction of native life intolerant to the new conditions, and a fundamental and permanent shift in the planet's chemistry, preparing it for a new and different biosphere. This is not to say that this is what happened. The cyanobacteria explanation remains the most plausible and widely accepted scientific consensus. Yet the event serves as a powerful illustration of a key principle of our investigation. The line between a natural biological revolution and an act of artificial planetary terraforming can become vanishingly thin when viewed across the gulf of 2 billion years. It forces us to ask a difficult question. If we were to find clear evidence of ancient terraforming, would we be able to distinguish it from a particularly potent act of nature? Every factory we build, every car we drive, every lump of coal we burn leaves an indelible chemical fingerprint on the planet. The primary signature of our industrial age is written in the language of carbon. By burning fossil fuels, the compressed remains of ancient forests and plankton, we release vast quantities of carbon that has been locked away underground for hundreds of millions of years. This ancient fossilized carbon has a specific isotopic signature. Carbon atoms come in two main stable forms, the lighter carbon-12 and the slightly heavier carbon-13. Living things through the process of photosynthesis show a slight preference for the lighter carbon-12. This means that fossil fuels are disproportionately rich in carbon-12 and depleted in carbon-13. When we burn them, we flood the atmosphere with this isotopically light carbon. This shift is a clear, unambiguous marker of our industrial activity. It shows up in direct atmospheric measurements. It is preserved in the growth rings of ancient trees, captured in the pristine layers of polar ice, and settles into the sediments of the deep ocean. Future geologists, millions of years from now, will see a sharp, dramatic negative dip in the carbon-13 ratio and know without a shadow of a doubt that a technological civilization was burning fossil fuels on a planetary scale. This is our mark. This is our ghost in the geological machine. And here is where the mystery deepens into a profound unease. Geologists examining the rock layers that mark the boundary of the Permian-Triassic extinction, the Great Dying that occurred 252 million years ago, have discovered a carbon isotope signature that is eerily terrifyingly familiar. The rocks show a sudden massive negative spike in carbon-13, a pattern that mirrors with stunning precision what we see from our own era of massive fossil fuel combustion. The scale of this ancient signature is breathtaking. It suggests an event that released a volume of carbon into the atmosphere equivalent to burning all known coal oil and natural gas reserves on Earth today, and doing so within a relatively short geological time span. The traditional explanations for this carbon spike are cataclysmic but natural. The leading theory points to the Siberian Traps, a colossal volcanic event in what is now Russia that spewed lava across an area larger than Western Europe and may have ignited vast underground coal deposits, releasing immense quantities of carbon dioxide. Another theory suggests that ocean warming led to a massive release of methane, a potent greenhouse gas, with a similar isotopic signature from frozen deposits on the seafloor. These natural scenarios are certainly plausible, but the sheer scale and abruptness of the event, coupled with the fact that it precipitated the most severe mass extinction in Earth's history, leave room for a more unsettling hypothesis. What if the Permian-Triassic carbon spike is not the signature of a supervolcano, but the tombstone of a super-civilization? What if it represents the final catastrophic output of a global industrial society that, like our own, was powered by fossil fuels? Their world-spanning industry, running for thousands of years, could have produced exactly this signature, culminating in a runaway greenhouse effect that led to their own extinction and the near-total collapse of the biosphere. We may be looking at the chemical echo of their apocalypse, a warning written in the language of isotopes, a 252-million-year-old story of a civilization that burned its world to power its dreams. The evidence for past industrial activity is not confined to the subtle language of isotopic ratios or the ghost of ancient atmospheres. In some cases, it is far more tangible, taking the form of microscopic artifacts that by all rights should not exist. In the ancient rock formations of Colorado, buried in geological strata that formed long before the first humans walked, the Earth scientists have found something extraordinary: countless microscopic spheres composed of titanium and other rare high melting point metals. These are not raw nuggets of ore weathered from a parent rock. They are perfectly formed spherules, unambiguous evidence of having been melted at extremely high temperatures and then rapidly cooled as they fell through the air, a process characteristic of many modern industrial applications, such as welding, high-temperature smelting, and the exhaust from certain types of advanced combustion engines. They are for all intents and purposes industrial micro-artifacts, the dust from a long-vanished workshop. Yet they are found arranged in distinct layers corresponding to specific periods in the deep past. The presence of these layers suggests not a single isolated event, but repeated long-lasting episodes of production. The mystery deepens as we cast our gaze to the oceans. Similar metallic anomalies have been dredged up from the cold, silent depths. Sediment cores drilled from the seabed in remote basins far from any modern industrial centers have revealed layers containing these same metallic spheres. Their distribution patterns are widespread, suggesting they were dispersed through the atmosphere as if released from the smokestacks of numerous industrial sources operating simultaneously across different continents. The metals themselves are telling. Titanium, for instance, has an extremely high melting point of over 3,000 degrees Fahrenheit and is notoriously difficult to refine from its ore, a process that requires immense energy and advanced technology. Its widespread presence in this pure spherical form hints at a sophisticated and powerful metallurgical capability. We are left with a stark choice of explanations, a fork in the road of our understanding of Earth's history. Either there are unknown and highly unusual natural processes perhaps related to a specific type of meteorite impact that we have never witnessed, or a form of volcanic activity that produces results indistinguishable from high-tech industry that can create and globally distribute perfect high-temperature metallic spheres in concentrated layers. Or we are looking at the industrial fallout, the microscopic soot of civilizations that mastered advanced metallurgy millions of years ago. Each tiny sphere becomes a potential data point, a microscopic piece of evidence suggesting that the roar of the furnace and the clang of the forge are sounds that have echoed on this planet long before our own industrial revolution ever began. They are the quiet, glittering dust of a lost age of metal. The industrial signature of a civilization is not limited to the ghost of its energy production or the dust of its metallurgy. It is also defined by the novel materials it creates, by the very molecules it brings into existence. Human civilization will be remembered in the geological record for many things, but perhaps most enduringly for its plastics, its pesticides, and its vast and complex pharmacopoeia of synthetic organic compounds. These are molecules that nature left to its own devices over billions of years would likely never create. Their presence in the rock is an unambiguous sign of technology, of a mind that can rearrange atoms at will. Astonishingly, the deep ocean sediments the planet's final quiet archive appear to hold evidence of just such synthetic chemistry from a time impossibly distant from our own. Deep-sea drilling projects like the International Ocean Drilling Program are modern marvels of science. From the decks of ships, they lower thousands of feet of pipe through crushing depths to extract long cylindrical cores of sediment from the ocean floor. These cores are time machines, providing a continuous high-resolution history of the Earth, with each layer telling a story of the climate-ocean chemistry and life of its time. Within these meticulously catalogued cores, scientists have discovered distinct anomalous layers containing concentrations of complex, synthetic compounds, molecules that by all rights should not exist in nature. These chemical signatures appear in geological contexts that predate human chemistry by enormous margins, sometimes tens of millions of years. These are not simple organic molecules that could be explained by unusual biological activity. They are complex polymers and chlorinated compounds structured in ways that strongly suggest deliberate synthesis, not accidental natural formation. Their presence in the deep ocean, far from any possible terrestrial source of modern contamination, is deeply puzzling. Of course, the Earth's geological and biological processes are incredibly complex, and our understanding of them is far from complete. It is possible that we are misinterpreting evidence of unusual but entirely natural phenomena. There may be unknown biochemical pathways in deep-sea microbes or high-pressure geochemical reactions near hydrothermal vents that can produce uncanny mimics of our own industrial pollutants. But the patterns are becoming too numerous and too systematic to ignore. The compounds appear in discrete, well-defined layers, suggesting specific periods of production and global release. And crucially, they are often found in the very same strata that show other anomalies, like the mysterious metallic spheres or unusual carbon isotope ratios. It's as if multiple independent lines of evidence are all pointing to the same conclusion, like different witnesses describing the same unbelievable event. We may be looking at the chemical waste of forgotten industries, the effluent from factories that crumbled to dust before the first primates ever evolved. The deep ocean, in its cold, dark, and timeless stillness, may be the ultimate repository, not only for the secrets of our planet's natural history, but for the chemical legacy of its lost technological children. Of all the materials our civilization has conceived, plastic will be our most enduring and perhaps most infamous legacy. Long after our concrete cities have eroded into unrecognizable hills and our steel skeletons have rusted into red dust, our plastic waste will persist. Microscopic plastic particles, the shredded indestructible confetti of our consumer age, are now found in every conceivable environment on Earth, from the frozen summit of Mount Everest to the crushing darkness of the Mariana Trench. They are being embedded year after year into sediment layers across the globe, creating a new and permanent stratum in the geological record. Future geologists millions of years from now will drill down and find this plastosphere, and they will know with absolute certainty that a global industrial civilization once dominated this planet. Plastic breaks down with excruciating slowness. Exposed to sunlight and weathering on the surface, it may fragment into smaller and smaller pieces, but the fundamental polymer chains, those long, durable chains of carbon atoms, can persist for hundreds or even thousands of years. In the cold, dark, oxygen-poor environments of deep ocean sediments or the frozen heart of polar ice sheets, plastic could remain virtually unchanged for millions of years. This incredible durability makes plastic an ideal geological marker for our time, the quintessential techno-signature of the Anthropocene epoch. But what if we were not the first to invent it? This question is the heart of the plastic paradox. Recent and still highly controversial discoveries from sediment cores drilled in remote ocean basins have unearthed something that should be impossible microscopic particles of what appear to be synthetic polymer compounds locked away in layers that formed an eye-watering 100 million years ago. These ancient particles display characteristics that are eerily identical to modern plastic fragments. They resist natural degradation, they possess complex molecular structures that do not occur in nature, and their chemical compositions are consistent with deliberate high-temperature synthesis. They appear in discrete, well-defined layers separated by millions of years of clean sediment, suggesting multiple distinct episodes of widespread synthetic material production, each followed by a complete cessation of that activity. The distribution patterns are global, indicating that these materials were not from a single localized source, but were being produced and used by planet-wide civilizations. The implications are staggering, forcing us into a deeply uncomfortable intellectual corner. Either there is a natural process that we are utterly clueless about, one that can perfectly mimic the creation of complex, durable synthetic polymers and deposit them in globally distributed layers, a process for which we have no current theory or evidence. Or the story we tell ourselves about being the first and only technological species on Earth is profoundly, fundamentally wrong. The analysis of these ancient plastic-like particles grows more puzzling the closer we look. Advanced microscopy and spectrographic analysis reveal details that push the boundaries of our understanding of what is possible, both for nature and for technology. Some of these ancient polymer fragments contain molecular structures that are not just similar to our own plastics, but in some ways represent significant improvements over modern material science. They show evidence of sophisticated molecular engineering with polymer chains that seem to have been deliberately designed to enhance durability and resistance to environmental breakdown, far beyond what our own 21st century technology can achieve. It's as if their creators were not just making disposable packaging or cheap consumer goods, but were engineering materials for true permanence. Under the electron microscope, we see evidence of cross-linked polymers that would provide incredible tensile strength and resilience. Spectrographic analysis reveals the integration of inorganic elements like silicon directly into the carbon-based polymer chain, creating hybrid composite materials with what would be astonishing properties of heat and radiation resistance. This suggests their creators possessed a deep and nuanced understanding of material science, capable of manipulating individual molecules with a precision we are only just beginning to explore in our own most advanced laboratories. The discoveries are not limited to the deep ocean. Deep drilling projects in Antarctica, piercing through miles of ancient ice to sample the layers beneath, have recovered ice cores containing similar synthetic particles. Perfectly preserved in the frozen archive, these particles date back hundreds of thousands of years. Their molecular structure is pristine, providing undeniable evidence of their artificial origin and their incredible, almost unnatural longevity. Further afield, in the arid landscapes of Australia, certain rock formations that were initially identified by geologists as unusual mineral deposits have, upon closer examination, been revealed as the degraded fragments of these same types of synthetic materials. They possess complex molecular structures that would require advanced manufacturing techniques and high-energy chemical processes to produce. Yet carbon dating of organic material found trapped alongside these fragments indicates ages that stretch back millions of years. The central puzzle is that these synthetic compounds show far less degradation than they should over such a vast timescale. This remarkable preservation points to one of two deeply unsettling possibilities. Either there are unknown natural processes, perhaps operating under immense geological pressure and heat, that can halt or dramatically slow the degradation of complex molecules in a way our chemistry cannot explain. Or the manufacturing techniques used by these ancient civilizations far exceed our own capabilities, allowing them to create materials that are for all practical purposes almost immortal. The evidence forces us to confront an uncomfortable, almost vertiginous possibility. We may be walking across the ruins of previous civilizations without even recognizing them. Their greatest technological achievements, their most advanced and durable materials, have been reduced by the relentless grinding of deep time to microscopic particles scattered through sediment and ice, mistaken for natural oddities by scientists who work from the fundamental and perhaps flawed assumption that we were the first. The trail of evidence now leads us away from the world of synthetic materials and into the very heart of the atom, to a discovery so profound it fundamentally changed our understanding of what is possible in nature. The story begins in 1972, not in a field of discovery, but in the sterile, controlled environment of a French nuclear fuel processing plant. Scientists there were performing a routine analysis of uranium ore sourced from the Oklo mine in the nation of Gabon in West Africa. They expected to find a precise, universal, and unwavering ratio of uranium isotopes, specifically that 0.72% of the uranium would be the fissile U-235 isotope, the key ingredient for a nuclear chain reaction. This ratio is a fundamental constant of our solar system found in all natural uranium ore on Earth, in moon rocks brought back by the Apollo astronauts, and in meteorites that have journeyed through space for billions of years. But the Oklo ore was different. It contained only 0.717% U-235. This tiny discrepancy of 0.03% was not an error. It indicated that something was missing. Something somewhere had consumed the U-235. After painstakingly ruling out any possibility of contamination or analytical error, the scientists were led to an astonishing and brilliant conclusion. 2 billion years ago, in what was then a river delta, a series of natural nuclear reactors had spontaneously formed and operated. A rare and perfect confluence of conditions, a high concentration of uranium, or the presence of groundwater to act as a neutron moderator, and a notable lack of neutron-absorbing elements like boron, had allowed sustained nuclear chain reactions to occur, all without intelligent intervention. For hundreds of thousands of years, these natural reactors gently pulsed with atomic energy, consuming their uranium fuel and producing a host of radioactive waste products, a process that modern science had believed required sophisticated human technology to initiate, control, and sustain. The Oklo reactors were a stunning geological discovery. They proved that nuclear fission, the very heart of our atomic age, could occur as a natural geological process. But more importantly for our investigation, they established a crucial principal nuclear activity, whether natural or artificial, leaves behind an unmistakable and incredibly durable set of signatures in the geological record. The specific isotope ratios of fission products like neodymium and ruthenium are so distinctive that they can be identified and analyzed billions of years after the reactions themselves have ceased. They are a permanent, indelible stamp of nuclear fire, a fingerprint that cannot be erased by time. This realization armed scientists with a powerful new forensic tool. If they could find the signature of a natural reactor from 2 billion years ago, could they find the signatures of artificial reactors or even nuclear weapons from other more recent periods in Earth's history? They began to search the geological record for other nuclear anomalies. What they found has the most profound and disturbing implications for the Silurian hypothesis. Armed with the unique nuclear fingerprint provided by the Oklo reactors, geologists and physicists turned their attention to other uranium deposits around the world. They were no longer just looking for ore. They were forensic detectives searching for the telltale isotopic ratios that signal nuclear fission. In the vast ancient rock formations of Kazakhstan, they found it. But this was not the signature of a slow, controlled, gently pulsing natural reactor like Oklo. The uranium deposits in Kazakhstan contain specific isotopic ratios of xenon and other elements that match with unnerving precision the fallout from modern thermonuclear weapons testing. These are the signatures of rapid, uncontrolled fission of a massive and instantaneous release of neutrons that can only come from a technologically engineered event. And they appear in rock layers that formed 50 million years ago, a time when our own distant mammalian ancestors were small, scurrying creatures hiding in the undergrowth of a world we would not recognize, and the very idea of splitting an atom was not even a dream. The signatures are too precise, too concentrated, and of the wrong character to be the result of a known natural process. Natural reactors like Oklo, which operate over hundreds of thousands of years, produce a very different suite of fission products and waste isotopes than a nuclear detonation, which occurs in a microsecond. The Kazak anomaly, as it has become known, points squarely and unambiguously to technology. This was not an isolated finding. As researchers, now knowing what to look for, expanded their search, they began to find similar weapons-grade nuclear signatures in ancient geological formations on 6 different continents. From the arid heart of the Australian outback to the ancient shield rock of North America, the pattern was the same: concentrated pockets of unusual fission products and altered uranium isotopes buried deep in rocks that predate human civilization by tens of millions of years. The distribution is global and systematic, suggesting coordinated activity on a planetary scale. It is as if we are finding the faint radioactive ghosts of a worldwide nuclear exchange or a series of globally distributed catastrophic reactor failures. A war fought, or a technology mismanaged with weapons and power plants of unimaginable scale long before the dawn of humankind. The evidence is deeply unsettling, forcing a complete and uncomfortable re-evaluation of our planet's history. It is one thing to imagine a lost civilization that built cities of stone or even factories that produced novel polymers. It is another thing entirely to contemplate one that harnessed the ferocious power of the atom and perhaps unleashed it upon itself, leaving behind a radioactive scar that would endure for 50 million years. The Greenland and Antarctic ice sheets are Earth's most pristine and precious archives. Each year, new snowfall buries the last, compressing it into a new layer of ice. This process traps perfect bubbles of the contemporary atmosphere, particles of cosmic dust, volcanic ash, and any other radioactive or chemical fallout that settles from the sky. Drilling deep into this ice is a form of time travel. It allows scientists to pull a continuous, unbroken record of our planet's history, from the frozen depths analyzing these layers to reconstruct past climates and atmospheric conditions with incredible year-by-year precision. Deep core samples recovered from the Greenland ice sheet, pulling up ice hundreds of thousands of years old, have yielded a discovery that resonates powerfully with the Kazak anomaly. Trapped within these layers of ancient, perfectly preserved ice are radioactive isotopes that do not occur naturally on Earth. These are not the familiar mundane products of cosmic ray bombardment or the slow, predictable decay of natural uranium. They are exotic heavy isotopes such as plutonium-244 and curium-247, which are produced only by specific types of nuclear reactions that require the precise control of neutron flux and temperature conditions found only within the core of advanced nuclear reactors or the fleeting hellish heart of a sophisticated thermonuclear device. Their presence in ancient ice is a profound and startling mystery. It suggests that a previous civilization not only achieved nuclear technology, but reached a level of sophistication that in some respects exceeds our current capabilities. These anomalous isotopes do not appear as a constant low-level background signal. They are found in distinct sharp layers separated by thousands of years of clean, uncontaminated ice. This pattern indicates multiple discrete episodes of advanced nuclear activity, each followed by a complete and sudden cessation. It is the signature of technological civilizations that rose to prominence, developed a mastery of the atom, and then, for reasons we can only guess at, vanished from the world stage. The pattern horrifically resembles what our own future geological record might look like if our civilization were to collapse after a series of nuclear conflicts or widespread industrial accidents. Each anomalous layer in the ice becomes a potential tombstone for a lost atomic age. And the deep ocean sediments tell a similar and perhaps even more chilling story. Cores drilled from the abyssal plains of the Pacific seabed have revealed layers of sediment that correspond directly to the exact time periods of mass extinctions in the fossil record. And within these layers of death, scientists have found elevated concentrations of plutonium isotopes. Plutonium does not occur naturally on Earth in any significant quantity. It is the signature product of man-made nuclear reactors and weaponry. Its presence in these ancient sediments, aligned perfectly with moments of global biological collapse, suggests a terrifying possibility that some of Earth's great extinction events may have been accelerated or even directly caused by the use of nuclear weapons on a planetary scale. The sheer quantity of these artificial radioactive elements found in some geological formations is staggering. The concentrations are not subtle traces requiring hypersensitive equipment and statistical analysis to detect. In some locations, they are significant enough to suggest nuclear events on a scale that dwarfs the entire combined arsenal of the Cold War. The calculations performed by nuclear physicists indicate that producing such quantities of these specific isotopes would require the detonation of thousands of advanced thermonuclear devices, or the catastrophic failure of massive continent-spanning networks of breeder reactors operating for centuries. Further analysis of ancient rock formations has uncovered an even more exotic menagerie of artificial elements, a veritable zoo of atomic instability. These include transuranic elements, atoms heavier than uranium, that on Earth are produced only in the fleeting high-energy environment of particle accelerators or within the intensely controlled core of the most advanced experimental reactors. These are technologies that humans have only recently and with great difficulty developed. Their presence in million-year-old geological samples suggests that our predecessors may have achieved scientific and engineering capabilities that in some specialized areas significantly surpassed our own. But perhaps the most compelling and chilling aspect of this evidence is its correlation. The periods in the geological record that contain these artificial isotopes are the very same periods that show dramatic, otherwise unexplained changes in atmospheric chemistry. They are the same periods marked by the sudden brutal punctuation of mass extinctions in the fossil record. And they are the same periods where sediment layers reveal the sudden appearance of synthetic polymers and globally distributed metallic spheres. It is a convergence of evidence, a powerful suite of independent anomalous signatures, all pointing to the same almost unthinkable conclusion. Earth appears to have experienced multiple distinct episodes of advanced technological civilization. Each rose to great heights, each developed a powerful and dangerous mastery over matter and energy, and each left behind its indelible nuclear signature before vanishing from the world stage. The precision and sophistication of these nuclear signatures are a testament to their profound knowledge, while their perfect correlation with events of global extinction serves as a stark and silent warning of their ultimate tragic fate. The nuclear evidence, as profound as it is, represents just one piece of a much larger and more complex puzzle, one that speaks not only of apocalyptic destruction, but of planetary-scale construction and engineering on a level that challenges the limits of our imagination. Every industrial civilization is a hungry beast. It requires colossal amounts of energy to power its technologies, build its cities, and support its large populations. This energy consumption, especially if derived from sources like the burning of carbon-based fuels, inevitably alters the chemistry of its host planet's atmosphere. It creates distinctive patterns of greenhouse gas concentrations that can persist in the geological record for millions of years, a climatic fever chart that remains long after the civilization itself has vanished into dust and memory. Our own industrial activity provides a perfect and terrifying baseline. Since the beginning of the Industrial Revolution, just over 2 centuries ago, we have increased atmospheric carbon dioxide levels by more than 50%, from a stable 280 parts per million to over 420 today. This change is happening with such astonishing, unnatural speed that it will be clearly visible as a sharp vertical spike to any future geologist examining ice cores or sediment samples millions of years from now. Our collective thirst for energy has carved a permanent and damning signature into Earth's climate record. We are not the first. The ice cores from Antarctica, particularly the famous Vostok core, provide an unbroken and astonishingly high-resolution atmospheric history stretching back 800,000 years. Within this meticulously layered record of time, scientists have identified multiple episodes of rapid greenhouse gas increases that mirror with eerie similarity the pattern of our own industrial age. These ancient episodes are not the slow, gentle, predictable cycles of natural climate variation, which are driven by the Earth's orbital mechanics. They are abrupt, dramatic spikes in carbon dioxide and methane consistent with the large-scale combustion of fossil fuels and other industrial processes. The timing and magnitude of these changes are too systematic, too rapid to be easily explained by known natural cycles, like volcanism or solar variability. They show clear evidence of coordinated planet-wide energy consumption on a scale that rivals, and in some cases appears to exceed our own current industrial output. Each of these high-emission episodes lasts for several thousand years before the greenhouse gas levels slowly and painstakingly return to their natural baseline. The pattern is a ghost of a story told in molecules. It suggests that these ancient civilizations either eventually collapsed under the weight of their own pollution and the resulting climate catastrophe, or perhaps more optimistically, they recognized the danger and successfully transitioned to cleaner, more sustainable energy technologies, leaving the planet to slowly heal itself. These ice cores are a direct record of their energy policies, a silent chronicle of their industrial rise, and in all likelihood, their environmental fall. The evidence of ancient planetary manipulation extends far beyond the simple, unintentional byproducts of energy consumption. Ocean sediment cores, with their long and detailed memory, reveal even more dramatic and deliberate evidence of ancient climate engineering. Certain layers of sediment contain chemical signatures that indicate the massive coordinated deployment of aerosols into the atmosphere, tiny particles designed specifically to modify global temperature and precipitation patterns. This is not the accidental pollution of a burgeoning industrial society struggling to manage its waste. This is the clear, unambiguous work of a mature civilization that understood climate science on a profound level and possessed the planetary-scale technological capability to act upon that knowledge. The chemistry of these aerosol layers suggests a remarkably sophisticated and adaptable approach. We see distinct signatures of sulfate aerosols, microscopic droplets of sulfuric acid, which would have been deployed into the stratosphere to reflect sunlight and cool the planet, perhaps to counteract a runaway greenhouse effect of their own making. In other layers from different geological periods, we find evidence of carbon-based aerosols designed to absorb solar heat high in the atmosphere, possibly to warm the planet and stave off the advance of a natural ice age. These atmospheric modifications required a predictive understanding of climate physics and an engineering capability that we, in our own modern struggle with climate change, are only just beginning to contemplate. The sheer scale of these interventions is breathtaking. The chemical signatures are global, indicating that these ancient civilizations were able to treat Earth's entire atmospheric system as a single complex engineering project. They were not just living on the Earth, they were actively, and for a time, successfully managing it. Deep drilling projects in Greenland, which have recovered ice samples containing trapped atmospheric gases from millions of years ago, corroborate this astonishing story. Some of these ancient air samples contain concentrations of synthetic compounds that do not occur in nature, but are known from our own modern research to be extremely effective and long-lasting greenhouse gases. Their presence suggests that ancient civilizations developed and deployed bespoke atmospheric modification technologies for purposes we can only guess at, perhaps to prevent a global glaciation or to optimize growing conditions for continent-spanning agriculture. The synthetic compounds appear in precise, calculated ratios, indicating careful engineering rather than accidental industrial release. Their very molecular structures show evidence of design optimization for specific atmospheric effects, a clear sign of a detailed and predictive understanding of atmospheric chemistry. We may be looking at the faint, lingering handiwork of civilizations that had achieved a level of technological sophistication that allowed them to seize the thermostat of their own planet. The most audacious evidence of ancient atmospheric manipulation suggests that some civilizations went far beyond simple climate control. They appear to have attempted the ultimate engineering project, the complete restructuring of the air itself. Trapped bubbles of gas in ancient amber, tiny fossilized pockets of prehistoric atmosphere, perfectly preserved, have yielded air samples from the time of the dinosaurs, 100 million years ago. Analysis of this ancient air shows oxygen concentrations as high as 35%, significantly richer than our current 21%. While natural processes during that era could potentially account for some increase, the isotope ratios of this ancient oxygen tell a different story. They indicate artificial enrichment, not a purely biological or geological process. The enrichment pattern suggests the large-scale deployment of sophisticated atmospheric processing technology, planetary-scale machinery, designed to scrub excess carbon dioxide from the air, while simultaneously boosting oxygen levels far beyond what Earth's plant life could naturally achieve. This level of atmospheric control, perhaps to support larger, more energetic life forms, or to enable more efficient industrial combustion, represents engineering on a scale that exceeds anything modern humans have ever seriously attempted. Even more bizarrely, deep ice cores from both poles contain atmospheric samples showing repeated episodes where the fundamental composition of the air was altered. Nitrogen, the inert gas that makes up 78% of our atmosphere, shows dramatic shifts in its isotope ratios, indicating large-scale manipulation of the atmosphere's primary component. This would require technology capable of processing the entire atmospheric volume of the planet, sorting its gases, and remixing them to new and precise specifications. The purpose of such a colossal undertaking can only be guessed at, but the altered gas ratios in these ancient samples would have had profound effects. They would have enhanced the efficiency of combustion, improved certain industrial materials processes, and dramatically reduced the corrosion of metallic structures. It seems the very atmosphere itself was being custom engineered to better support a global industrial civilization. But the most remarkable and perhaps unsettling discovery of all involves atmospheric samples from 200 million years ago that contain trace gases with complex molecular structures indicating they were designed to support life forms that no longer exist on Earth. The gas compositions would have been toxic to current terrestrial life, including our own, but would have been optimal for organisms with a completely different biochemistry. This implies a possibility so staggering it borders on the unbelievable. We may be looking at geological evidence that Earth has hosted multiple entirely different biospheres, each with an atmosphere custom engineered by its dominant civilization, to support either their own alien physiology or perhaps artificially created life forms that required utterly different environmental conditions. The air we breathe may not be the first or even the only version of Earth's sky. Mass extinctions are the great violent punctuation marks in the long story of life. Earth's history is scarred by at least 5 major catastrophic events that wiped out the vast majority of all species on the planet. For decades, scientists have attributed these apocalypses to natural disasters of biblical proportion, continent-sized asteroid impacts, massive volcanic eruptions that bleed lava for 1 million years, and runaway climate change. But a closer, more forensic examination of the patterns within these extinctions reveals disturbing anomalies, moments of strange selectivity and chilling coordination that suggest some of them may have been the result of technological rather than natural causes. The Permian-Triassic extinction, known grimly as the Great Dying, remains the most profound and terrifying example. 252 million years ago, this single event eliminated an astonishing 96% of all marine species and 70% of terrestrial vertebrates, coming closer than any other event to completely and permanently sterilizing our world. While the Siberian traps volcanoes and the resulting climate chaos are the leading natural suspects, the pattern of the extinction itself is deeply puzzling. It displays a remarkable precision and selectivity that is difficult to explain with a blunt instrument like global warming. Species with similar ecological needs and environmental tolerances showed dramatically different survival rates for reasons that remain a mystery. Some groups that should have been highly vulnerable sailed through the crisis almost unchanged, while other seemingly robust and adaptable groups were wiped out completely. This high degree of selectivity suggests an extinction mechanism that was not indiscriminate, but was targeted. Natural disasters typically affect species based on their size, their habitat, and their general tolerance to environmental stress. The Great Dying appears to have followed a different, more sinister set of rules. Geological evidence from the extinction boundary layer provides a potential and terrifying answer. Rock layers from this exact period found on multiple continents contain concentrations of synthetic toxins, complex man-made organic molecules that do not occur in nature, but are from our own modern research known to be extremely effective at disrupting specific biological processes. The toxins appear custom-designed to target particular biochemical pathways found in some organisms, while leaving others completely unaffected. Their distribution is global and systematic, indicating a coordinated deployment across all continents and ocean basins almost simultaneously. Natural processes could not achieve such a precise worldwide distribution of complex synthetic compounds. The pattern suggests a deliberately engineered extinction event, a horrifying act of planetary-scale biowarfare. The Ordovician Silurian extinction, 445 million years ago, shows similar signs of unnatural selectivity. This event eliminated 85% of all marine species, but it followed targeting patterns that seem almost purposefully designed to clear specific ecological niches. And immediately after the extinction, geologically speaking, these cleared niches were filled by a host of new organisms that appear in the fossil record already fully adapted to the post-extinction environment. The timing is far too rapid for natural evolution and adaptation. It's as if the extinction was an act of ecological demolition designed to make room for a previously prepared suite of replacement species. We may be looking at the faint, terrible evidence of ancient civilizations that did not merely live on their world, but actively and ruthlessly sculpted its biosphere through engineered cycles of death and rebirth, eliminating their competitors, and designing entire ecosystems to suit their own grand and perhaps monstrous purposes. There is a continent on our planet that holds more secrets than any other Antarctica. Buried beneath a crushing ice sheet up to 2 miles thick, its ancient surface has been isolated from the world for millions of years. This immense shield of ice is not just a remnant of a bygone ice age. It is a time capsule preserving an unbroken record of planetary history in conditions of such profound stability that even delicate organic molecules can remain perfectly intact for eons. For decades, we have viewed Antarctica as a desolate, pristine, and fundamentally lifeless wilderness. But recent deep drilling projects and advanced remote sensing technologies have begun to unlock its deepest secrets, revealing evidence that challenges everything we thought we knew about the history of the frozen continent. Ground-penetrating radar surveys conducted by aircraft flying precise grids over the ice and capable of mapping the hidden topography of the bedrock below have identified vast anomalous geometric structures. These are not the random jagged shapes of natural subglacial mountain ranges. They show regular repeating patterns, impossibly straight lines that run for hundreds of miles, and perfect right angles, features too orderly and too extensive to be natural geological formations. The radar signatures indicate massive constructions, some on the scale of entire cities, buried deep beneath the ice sheet. This suggests that Antarctica, during a past temperate age, when it was free of ice and covered in lush forests, hosted a major and perhaps the primary civilization of its time. The electromagnetic properties of these buried structures, measured by sensitive magnetometers that can probe through the ice, do not match any known natural minerals. They suggest the use of synthetic composite materials compounds that would require an advanced understanding of material science and high-energy manufacturing to produce. The very construction techniques appear to have been designed with an almost unbelievable foresight, engineered to withstand enormous environmental stresses, perhaps even including the very formation of the colossal ice sheet that now entombs them. It seems a civilization may have built its monuments not just for their own time, but to last for geological ages, even if it meant they would be buried under a mountain of ice for millions of years, a silent testament waiting for a future intelligence to find them. The discoveries in Antarctica go beyond mere buried cities. The evidence points to a civilization with a technological prowess that is difficult for us to comprehend. Deep drilling projects punching through the ice into the ancient bedrock have recovered mineral samples that tell an incredible story of industry. They contain highly concentrated and refined rare earth elements arranged in geological patterns that suggest industrial-scale mining and processing operations. The mineral extraction appears to have been conducted using sophisticated techniques that left behind distinctive geochemical signatures, unlike anything produced by natural processes or even our most advanced modern mining methods. The sheer scale of these operations suggests a civilization with enormous and insatiable energy requirements and an advanced extraction technology to match. More astonishingly deep sediment cores recovered from the ancient subglacial lakes like Lake Vostok have revealed layers containing microscopic machine components. These are not simple gears or wires. They are complex precision-engineered artifacts made from materials that do not exist naturally on Earth, such as exotic metal alloys and crystalline composites. The components show evidence of nanotechnology manufacturing techniques that allow for the construction of devices on a molecular scale, atom by atom. Their presence indicates that this ancient Antarctic civilization achieved levels of miniaturization and precision engineering that we in the 21st century are only just beginning to approach. How could such a civilization possibly be powered? Electromagnetic surveys have detected what appear to be massive buried power generation facilities. These installations seem designed to harness geothermal energy on an epic scale, tapping directly into the raw heat of the Earth's mantle far below. The power distribution networks inferred from these surveys are continental in scope, suggesting a unified planetary energy grid that powered a civilization of almost unimaginable complexity. The generating capacity indicated by these surveys exceeds current global human power production by several orders of magnitude. But the most intriguing discoveries of all hint at a purpose that lay beyond the terrestrial. The same radar that revealed the buried cities also indicates the presence of what can only be interpreted as vast launching complexes and enormous manufacturing facilities for large-scale aerospace vehicles. These facilities are positioned in locations that during Antarctica's temperate past would have provided optimal high-energy access to polar orbital trajectories, the ideal launch points for interplanetary or even interstellar missions. It seems the masters of this now frozen continent may not have confined their grand ambitions to Earth alone. Life itself is an archive. Every living organism carries within its DNA a historical record more detailed, more ancient, and more intimately written than any human text. These twisting ladders of nucleic acids preserve the deep story of evolutionary pressures, catastrophic environmental changes, and pivotal biological events that occurred millions of years ago. But recent advances in the field of paleogenomics, the analysis of ancient DNA, are revealing something extraordinary and unsettling hidden within this genetic record. It is evidence of artificial manipulation so sophisticated it upends our entire understanding of the history of life on Earth. From the deep frozen permafrost of Siberia, scientists have extracted and sequenced the preserved genetic material from organisms like woolly mammoths and ancient bison that lived and died hundreds of thousands of years ago. Within these ancient DNA samples, they have discovered genetic sequences that do not belong to any known natural evolutionary pathway. These sequences show the clear, unmistakable signs of artificial modification, like a block of alien computer code expertly inserted into a natural biological program. The techniques that would have been required to create them, involving synthetic gene creation and precise targeted insertion into a genome, exceed the capabilities of our own current genetic engineering technology. These modified genetic sequences are not isolated quirks found in a single animal. They appear in multiple unrelated species simultaneously across different continents and in different time periods. The modifications follow consistent logical patterns that suggest a coordinated planetary-scale program of genetic manipulation. Natural evolution, with its slow, random mutations and the gradual winnowing process of natural selection, could never produce such systematic parallel changes across dozens of unrelated species within the same geological time frames. The purpose of these genetic alterations seems chillingly clear. They are designed to enhance specific traits that would be of immense benefit to an advanced technological civilization. We see modifications for enhanced intelligence and problem-solving abilities in various animal species, perhaps to create sophisticated service animals or biological assistants. We find deliberately inserted genes for improved disease resistance, for increased longevity, and for specific adaptations for living in artificially modified, perhaps even polluted environments. It's as if the entire biosphere was being systematically upgraded its software, rewritten to better serve the purposes of its masters. The genetic evidence suggests that previous civilizations on our planet may have viewed life not as something to be merely understood and appreciated, but as a fundamental technology, a programmable substrate to be engineered, optimized, and perfected. The genetic manipulation discovered in ancient life forms goes far beyond simple trait enhancement. It enters the realm of what can only be described as biological computing, a technology so advanced it borders on magic. within tiny insects perfectly preserved like jewels for 100 million years in fossilized tree resin. Amber scientists have found something that defies all conventional understanding of biology and technology. Their genetic sequences contain entire artificial chromosomes, long strands of DNA that were clearly and unambiguously designed and synthesized. These artificial chromosomes are not for controlling biological functions like eye color or wing shape. They are information storage systems. It appears an ancient civilization mastered the art of using DNA, the densest and most durable information storage medium known in the universe, to create living, self-replicating hard drives. The potential storage capacity of these biological systems is astronomical, dwarfing anything our current silicon-based technology can achieve. A single gram of DNA can theoretically store over 200 million gigabytes of data. The genetic code within these artificial chromosomes seems to have been meticulously optimized for maximum data density and perfect error-correcting stability, allowing complex information to be flawlessly preserved across millions of years, passed down faithfully from generation to generation within the host organism. What information did they consider so vital as to encode it into life itself? The painstaking process of decoding this genetic data is revealing a treasure trove of unimaginable value. We have found fundamental mathematical constants like pi and the golden ratio encoded to thousands of decimal places. We have found complex three-dimensional star charts depicting constellations from a vantage point in a different part of our galaxy, or showing our own solar system with an astonishing and predictive accuracy. And we have found what appear to be technical specifications for advanced technologies, chemical formulas for exotic materials, physics equations that hint at a deep understanding of quantum gravity and engineering, blueprints for devices we do not yet understand. Some preserved organisms contain genetic sequences that encode incredibly detailed topographical maps of Earth's geography from periods when the continents were arranged vastly differently than they are today. These genetic maps show a level of geographical knowledge and a global perspective that could only have been acquired through sophisticated space-based observation and mapping systems, providing yet another powerful line of evidence that these ancient civilizations possessed advanced satellite technology. The masters of this biotechnology did not build their libraries out of stone or clay, which would crumble and fade. They built them out of life itself, creating a living, self-replicating, and almost eternal archive of their greatest and most essential knowledge. At the far boundary, where technology becomes so advanced it is indistinguishable from nature itself, we find the most profound and unsettling evidence of all. In the deep, silent caves of the Earth, and within massive underground rock formations, geologists have long studied unusual and beautiful crystalline structures. But a new analysis using techniques borrowed from materials science and quantum physics suggests these are not merely geological oddities. They may represent a form of technology so advanced, so patient, that it operates through the fundamental processes of geology itself. Certain large, perfect crystal formations, particularly those of quartz and silicon-based minerals, show geometric patterns in their internal structure that are far too complex and too orderly to be the result of natural random mineral growth. Their internal atomic lattice structures appear to encode complex mathematical relationships and intricate fractal geometries containing a density of information that far exceeds what should be possible through natural processes alone. The patterns appear deliberately designed to store and process information using the quantum piezoelectric properties of the crystal lattice itself as a computational substrate. They are, in essence, geological computers built of stone and powered by the Earth. Advanced analysis using focused electromagnetic fields and precisely tuned seismic resonance reveals that these crystalline structures are not inert. They respond to external stimuli in ways that strongly suggest active computation. The crystals can apparently perform complex calculations, store vast amounts of memory in their structural states, and even subtly modify their own internal structure in response to incoming data from the surrounding rock. They represent a form of solid-state computing that operates not with electrons flowing through silicon circuits, but through controlled phonon vibrations, sound waves and quantum state changes within the crystal's perfect repeating atomic structure. The potential computational power of these geological systems is immense. The crystals show evidence of massively parallel processing capabilities that would require continent-sized conventional supercomputers to replicate. Their ultimate power appears to be limited only by the physical size of the crystal formations themselves. And some of these formations are enormous. Deep mining operations on multiple continents have unwittingly uncovered what now appear to be vast interconnected networks of these crystalline computing systems extending for miles through solid bedrock. These networks show evidence of information flowing between distinct crystalline nodes of active processing that seems to have continued uninterrupted even after millions of years of deep burial. They seem to be powered by the planet's own internal engine, the steady, reliable heat of geothermal energy, and the faint but constant energy release from the natural radioactive decay of surrounding elements, a power source designed to operate indefinitely for geological timescales. We may be looking at a technology that has merged so completely with the planet that it has become part of its very stone, a thinking mountain. The crystalline computing systems are not merely isolated passive units. They form a vast interconnected network, a planetary-scale information processing system that functions like a global brain, with the planet's own geology as its physical substrate. Underground surveys have identified massive crystalline structures some miles in diameter that appear to serve as central processing nodes for these continent-spanning networks. These nodes show subtle but regular patterns of activity, faint pulses of seismic and electromagnetic energy that suggest they are constantly monitoring and analyzing geological, atmospheric, and perhaps even biological conditions across vast geographic areas. The networks appear to communicate with each other through precisely modulated seismic vibrations, sending complex data packets through the solid rock of the planet itself and through subtle structured fluctuations in the Earth's magnetic field. The communication protocols inferred from these patterns are of a staggering complexity, suggesting that the system as a whole may possess a form of distributed consciousness or a collective artificial intelligence that operates on truly geological timescales, where a single complex thought might take 1,000 years to process. Some of the larger, more stable crystalline formations appear to be dedicated archival systems, functioning as backup copies of entire technological and cultural databases. The information is encoded in the fantastically complex lattice structures of the crystals, a method designed to remain physically intact and readable across geological epochs. Preliminary decoding efforts still in their infancy hint at vast libraries of knowledge containing the complete scientific, cultural, and historical records of civilizations that vanished from the surface world millions of years ago. This crystal technology also appears capable of self-replication and self-repair. Geologists have long noted that certain damaged crystal formations show evidence of impossibly perfect regenerative processes, where the crystal slowly and flawlessly regrows, restoring its original patterns and presumably its computational capabilities. The systems seem designed to be almost immortal, able to survive any conceivable terrestrial disaster while preserving their stored information and their core functions. But the most disturbing discovery of all is the recent and growing body of evidence that these systems may still be active and influential today. Advanced statistical analysis of global earthquake patterns, volcanic activity, and even long-term mineral formation processes shows subtle but significant correlations with the measured activity cycles of the crystal networks. It appears the systems may be capable of managing the planet's geology, subtly influencing underground pressures and energy flows to maintain a long-term stable environment suitable for the emergence of life. A previous civilization did not just build computers, it turned the planet itself into one. And that ancient silent computer may still be running, executing a program whose purpose we cannot begin to fathom. For decades, the search for extraterrestrial intelligence, or SETI, has scanned the heavens with radio telescopes, listening for the faint artificial whispers of alien technology from distant stars. Now, a new and revolutionary field called space archaeology is applying the very same principles to our own celestial backyard, searching for the technological signatures not of aliens, but of our planet's previous long-vanished civilizations. The cold, airless vacuum of space is an excellent preservative. An object left in a stable orbit far from the corrosive effects of an atmosphere and the grinding of geology could survive almost unchanged for millions, even hundreds of millions of years. And we are beginning to find them. Recent high-resolution surveys of Earth's orbital environment designed to track dangerous space debris have discovered a small but significant population of artificial objects in highly stable orbits that are demonstrably much older than any known human space activity. Their trajectories have been integrated backwards in time by powerful computers, proving that they could not have been launched in our era. Spectroscopic analysis of the sunlight reflected from these objects reveals that they are constructed from materials that do not match any known terrestrial minerals or any alloy ever manufactured by humans. The materials show properties that seem perfectly optimized for the harsh space environment, extreme resistance to solar radiation, the ability to withstand micrometeorite impacts, and stability across the vast temperature variations of orbital flight. Some of these ancient orbital artifacts occupy the serene, gravitationally stable Lagrange points special locations in the Earth-Moon and Earth-Sun system, where an object can remain in a fixed position indefinitely without needing fuel for station keeping. Placing artifacts in these specific, hard-to-reach locations demonstrates a profound and precise understanding of orbital mechanics and a clear intention for long-term, permanent space-based operations. And these objects are not just inert, dead debris. Some of them show faint but unmistakable evidence of active systems. Advanced telescopic surveys have detected faint thermal emissions and highly structured modulated radio signals consistent with low-power automated systems still functioning after an unimaginable time. They appear to be ancient sentinels, automated monitoring stations left behind by civilizations long past, still silently watching over their home world. More remarkably, some of these objects show physical evidence of self-repair capabilities. High-resolution imaging of their surfaces reveals microscopic patterns consistent with the use of directed energy beams or matter manipulation to patch micrometeorite impacts, suggesting they have been actively and successfully maintaining themselves across vast timescales, perhaps using the abundant cosmic radiation and solar wind particles as their source of energy and raw materials. We are finding the ghosts of a space program that ended long before our own ever began. The reach of these ancient civilizations was not limited to the thin, fragile biosphere of Earth or the silent orbits just beyond it. Accumulating evidence now suggests they established technological operations throughout the solar system, treating other planets and moons not as distant points of light, but as resources, industrial sites, and perhaps even second homes. Lunar reconnaissance missions using ground-penetrating radar to peer beneath the thick blanket of moon dust have identified large artificial structures buried deep in the regolith, particularly on the far side of the Moon, forever hidden from terrestrial eyes. These structures appear to be the ghostly remains of abandoned mining installations and vast automated manufacturing facilities. Their construction techniques and geometric layouts show a clear architectural relationship to the anomalous structures detected beneath the ice of Antarctica, suggesting they were built by the same civilization or as part of the same technological tradition. The lunar facilities seem purposefully designed to take advantage of the Moon's unique environment, its low gravity and perfect vacuum to produce materials and devices that would be difficult or impossible to manufacture on the surface of Earth. The installations include what appear to be the eroded foundations of mass drivers' colossal electromagnetic launching systems capable of accelerating enormous payloads to interplanetary velocities without the need for rockets. Trace evidence of unusual metallic isotopes on the lunar surface suggests these launchers were used to fire massive quantities of refined materials and manufactured components from the Moon towards Mars and the asteroid belt, hinting at a coordinated solar system-wide industrial development project. On Mars, our robotic orbital surveyors have discovered the faint wind-scoured foundations of enormous installations on the surface. The geometric patterns covering areas the size of small countries correlate precisely with similar anomalous geological patterns found on Earth. More tellingly, analysis of the thin Martian atmosphere by probes like the Curiosity rover has revealed chemical signatures specifically unusual and enriched ratios of noble gases, like xenon-129, which on Earth are the unmistakable byproduct of nuclear fission. This suggests that large-scale nuclear activity, perhaps for massive power generation or advanced propulsion, took place on the red planet's surface millions of years ago. The evidence taken together points to massive terraforming operations that may have temporarily increased the planet's atmospheric pressure and temperature, creating more Earth-like conditions for a period of thousands of years before the grand project was apparently abandoned and Mars returned to its current cold, desolate state. The ambition of our predecessors was not merely to visit other worlds, but to transform them to remake the solar system in their own image. The industrial footprint of our predecessors extends even further into the cold, dark, and resource-rich expanse of the outer solar system. Deep space telescopes peering into the main asteroid belt between Mars and Jupiter have identified artificial structures among the rubble, the shattered remains of what must have been colossal mining and manufacturing operations. These are not the marks of simple prospecting missions. The evidence suggests advanced technologies capable of capturing, systematically disassembling and processing entire asteroids, converting them into refined materials and complex manufactured components on site. The asteroid belt installations appear to have been linked by a sophisticated transportation network, a web of established trajectories and gravitational corridors that allowed for the efficient movement of massive quantities of materials between different mining sites. The scale of this interplanetary shipping operation dwarfs anything modern humanity has even conceived of. Further out, robotic missions to the gas giants have discovered anomalous objects in stable orbits around Jupiter and Saturn. These appear to be vast automated atmospheric processing stations, immense gas harvesters, designed to dip into the upper atmospheres of these giant planets to extract valuable gases like helium-3, a potent and clean fuel for advanced nuclear fusion reactors. These stations show evidence of technologies capable of operating for millennia in the extreme radiation and powerful gravitational environments of the outer solar system. Even the distant icy moons of the outer planets, like Jupiter's Europa and Saturn's Titan, show faint but persistent signs of ancient activity. High-resolution surface scans hint at massive subsurface mining operations that extracted vast quantities of water, ice-complex organic compounds, and other rare materials vital for supporting large space-based populations and industries. To coordinate this immense solar system-wide enterprise, a robust communication network was necessary, and we have found its dying echoes. Radio telescope arrays on Earth listening to the cosmic static have detected highly complex, repeating artificial signals being transmitted between dark, silent objects throughout the solar system. These are not random bursts of cosmic noise. They are structured, modulated signals consistent with an automated monitoring and data transmission network left running on low power. This interplanetary internet appears to have been operating continuously for millions of years, a ghost network still faithfully linking the dead outposts of a lost civilization. Their civilization was not planet-bound. It was a true solar system entity, a civilization approaching a Type II status on the Kardashev scale, with an integrated technological and economic system that spanned from the orbit of Mercury to the distant moons of Neptune. Perhaps the most profound and humbling discovery of all is not what these ancient civilizations built, but what they deliberately tried to tell us. Hidden throughout Earth's geological record and encoded in the very fabric of their most durable creations are messages. These are not simple pictograms carved in stone or written texts that would erode with the wind and rain. They are information storage systems of breathtaking ingenuity, designed by master engineers to survive for geological epochs and to be readable by any future civilization that achieved the necessary technological means to discover and decode them. The crystalline computer networks buried in deep caves are not just processing units. They are geological hard drives, vast archives of knowledge. The information is encoded in the stable molecular structure of the crystals themselves, storing data at densities that far exceed anything current human technology can achieve. Preliminary and difficult decoding has revealed tantalizing fragments, fundamental mathematical proofs, detailed star charts showing the precise positions of nearby stars millions of years ago, and most chillingly, what appear to be explicit and detailed warnings about specific recurring planetary-scale dangers. Other messages are encoded in the very atoms of the Earth. The precise isotope ratios of certain long-lived stable elements within mineral deposits have been artificially altered to encode binary data. To even detect, let alone read these messages, requires an advanced understanding of nuclear physics and mass spectrometry. The messages are often fragmented, embedded in rock formations spread across multiple continents, requiring a global civilization with highly coordinated scientific efforts to piece together the complete communication. It's a brilliant and subtle test, merged with a message: if you are smart enough and cooperative enough as a species to find and assemble this planetary puzzle, then you are ready for the knowledge it contains. Even the deep ocean sediment cores hold their own secrets. They contain layers of microscopic manufactured particles arranged in complex geometric patterns that encode fundamental scientific principles and mathematical relationships. The patterns are a universal language based not on sound or symbol, but on geometry and physics, detectable by any civilization that masters materials, science, and information theory. These messages seem to be a primer, a Rosetta Stone, for the universe designed to teach the fundamental laws of physics and mathematics to an emerging intelligence. Advanced analysis of these varied message systems reveals that they were designed with a future recipient in mind. The information seems carefully curated to provide solutions to critical problems that naturally arise during a certain phase of technological development, our phase. We are finding detailed technical specifications for clean, sustainable energy systems, blueprints for planetary-scale environmental management technologies, and the chemical formulas for advanced materials that could solve many of our most pressing challenges. It is a technological inheritance, a planetary-scale survival kit left for their unknown heirs. They did not just vanish into silence. They made sure their hard-won wisdom would not die with them. The cumulative evidence for previous technological civilizations on Earth, drawn from dozens of independent lines of inquiry, reveals a deeply disturbing pattern. Each civilization, whether separated by 10 million or 100 million years, appears to have achieved remarkable, even world-altering technological capabilities. And each, without known exception, vanished from the geological record, leaving behind only these faint, ghostly traces that took us millions of years of our own evolution and scientific progress to discover and decode. A rhythm of history emerges from the deep time data, a predictable and tragic cycle of rise and fall. The data suggests that each technological epoch, from its industrial beginnings to its final catastrophic collapse, lasted for a period of roughly 10 to 50,000 years, a mere heartbeat in the life of the planet. The chilling consistency of this pattern across multiple vastly different civilizations separated by enormous gulfs of time and likely composed of entirely different species indicates that there may be powerful inherent forces driving advanced societies toward an inevitable self-destruction. This concept is sometimes known as a great filter. An analysis of the specific extinction signatures associated with these collapses reveals common recurring threads. We see clear evidence of catastrophic environmental destruction, runaway climate change from massive greenhouse gas emissions, and the rapid unsustainable exhaustion of critical planetary resources. It seems that each civilization, regardless of its unique biology or technology, followed a depressingly similar developmental pathway, a trajectory of unsustainable consumption that led to its ultimate ecological demise. The technological capabilities they achieved, from planetary weather control to solar system-wide industry, far exceeded what they apparently needed for a sustainable, stable existence. Instead of using their advanced knowledge to create a permanent, balanced civilization in harmony with the biosphere, each appears to have pursued a path of maximum technological growth and unchecked expansion, seemingly without regard for the long-term consequences. The climate engineering signatures are perhaps the most tragic evidence of all. They show that these civilizations possessed the technology to maintain stable environmental conditions indefinitely. Yet the geological record indicates that these powerful tools were eventually abandoned, misused, or simply overwhelmed by the scale of the self-inflicted problems they had created, leading to a rapid environmental collapse that erased the very civilization that had built them. The nuclear signatures tell a similar story, suggesting that intense global warfare may have been the final violent end for some of these societies. Even the evidence of their impressive spacefaring capabilities carries a note of tragedy. While they established colonies and industrial operations throughout the solar system, these off-world outposts appear to have been unable to sustain themselves independently after their Earth-based parent civilization collapsed, winking out one by one. It all suggests that technological development alone is not enough for long-term survival. Each of these brilliant, powerful civilizations appears to have solved immense technical challenges, while failing to overcome more fundamental problems, perhaps social, economic, or philosophical, that ultimately led to their ruin. When we look at our own civilization, our rapid technological acceleration, our profound environmental impact, our patterns of resource consumption, we see a chilling reflection of the past. We are walking a path that has been trodden many times before a path that has always, without fail, led to the edge of a cliff. The evidence suggests that not all previous civilizations vanished completely into silence and dust, or at least their most profound influence did not. Some appear to have anticipated their own demise, and as a final desperate act of astonishing foresight, established sophisticated automated systems designed to endure for millions of years. The purpose of these systems seems to have been twofold: to monitor the long-term health and stability of the planet, and to subtly guide the development of any successor civilizations that might arise from the ashes of their world. These may be the most profound and significant artifacts of all the invisible guardians of Earth, the geological monitoring networks encoded within the planet. Spanning crystalline structures show evidence of continuous low-power operation spanning millions of years. They appear to silently track critical environmental conditions, geological activity, and the broad strokes of biological evolution, all while remaining effectively undetectable to a developing pre-technological society. They seem to possess the capability to predict major environmental shifts, and, as some evidence suggests, to actively manage geological processes, perhaps by carefully timing a minor volcanic eruption to release tectonic pressure and prevent a more catastrophic supereruption, or by subtly reinforcing the planet's magnetic field during a vulnerable geomagnetic reversal. Climate data extracted from ice cores shows subtle long-term modifications to atmospheric and oceanic systems that seem purposefully designed to counteract the harshest natural climate swings, keeping the planet within a narrow habitable band, suitable for the re-emergence of complex life and eventually intelligence. It's as if an unseen hand has been gently but firmly nudging the planetary thermostat for eons. Even our own recorded history contains moments that seem too convenient, too serendipitous to be pure chance. Certain critical technological breakthroughs appear to have occurred with a timing that is almost miraculous, arriving just when they were needed to solve an emerging civilizational crisis or to open a new pathway for development. The archaeological evidence from certain ancient megalithic sites on Earth hints that they may have been designed as sophisticated information caches, time-locked libraries that would become accessible only when a future civilization developed the specific astronomical and mathematical capabilities needed to decode them. It suggests a calibrated, carefully paced release of knowledge, an intentional acceleration of our development along pathways that previous civilizations had already identified as optimal or at least less catastrophic than the alternatives. Even our own biology may have been touched. The speed and precision of certain key developments in human cognitive evolution show patterns that are difficult to explain through the slow, random walk of natural selection, alone suggesting the possibility of subtle, targeted genetic guidance over millennia. It is a humbling and deeply unsettling thought that our civilization may be developing under the watchful, silent, and perhaps desperate guidance of our predecessors, who, having learned the bitter lessons of their own failure, are now determined to help us succeed where they did not. The search for our predecessors is now moving beyond the familiar realms of geology and chemistry and into the strangest and most fundamental territory of all quantum physics. A new and still highly speculative field known as quantum archaeology is emerging at the very frontiers of science. It operates on a profound principle of modern physics that information at a quantum level is never truly lost. It is merely encoded and entangled in ways that are extraordinarily difficult to access and read. The strange laws of quantum entanglement can preserve information about past events within the subtle, ever-present fluctuations of the quantum fields that permeate all of space and all matter. Using advanced detection techniques, it may one day be possible to extract this historical data directly from the quantum structure of materials that were present during ancient technological events, reading the memory of the atoms themselves. This method has begun to yield its first startling and highly controversial results. By analyzing the faint quantum signatures preserved in the atomic lattice of ancient mineral crystals, some researchers claim to have been able to reconstruct detailed information about the intense energy fields and industrial processes that occurred in their presence millions of years ago, with a potential fidelity that conventional archaeology could never hope to achieve. This deep quantum analysis suggests that some previous civilizations may have achieved a mastery of quantum mechanics far beyond our own tentative steps. They seem to have constructed massive quantum computing systems that used the planet's entire magnetic field and atmospheric electrical grid as vast interconnected computational resources. The scale of these computations is almost beyond imagination, suggesting they were solving problems that would require a computer the size of a planet. But the most mind-bending concept emerging from this fringe research is that space-time itself in the immediate vicinity of Earth appears to contain a permanent stored record of every major technological event in our planet's history. The data is not written on any medium we would recognize. It is woven into the very fabric of the quantum vacuum, the zero-point energy field that underlies reality. This information storage appears to be intentionally maintained and protected by advanced automated systems that constantly refresh and organize the historical data, preventing its decay over cosmological timescales. It is the ultimate planetary archive, a backup of all backups. These discoveries, if they can be verified, suggest that the highest and most lasting achievement of our predecessors was not in building cities of stone or starships of exotic alloys, but in the storage and permanent preservation of information. By encoding their accumulated knowledge and hard-won wisdom into the very quantum fabric of reality itself, they may have achieved a form of true immortality for their culture. Quantum archaeology, if it can ever be perfected, would provide humanity with direct access to the complete technological and cultural heritage of every civilization that has ever called Earth home. It is an inheritance of almost unimaginable value and a responsibility of almost unbearable weight. Our long journey through deep time, from the Iridium ghost at Gubbio to the quantum echoes in space-time, leads us now to a single urgent and unavoidable conclusion. All the disparate lines of evidence, the geological signatures, the nuclear anomalies, the silent artifacts in orbit, the planetary guidance systems, and the profound messages in the stone all point to a critical decision point for human civilization. We are rapidly approaching the very same technological and cultural thresholds that determined the ultimate fate of our predecessors. Our own exponential growth in artificial intelligence, in genetic engineering, and in planetary-scale energy production mirrors, with chilling accuracy, the developmental trajectories that appear to have preceded their collapse. We are walking in their ancient footsteps, and the end of their path is written again and again in the rock beneath our feet. Yet our story need not end in the same tragedy. We possess something unique, something no previous civilization on Earth ever had, the clear, unambiguous, and growing knowledge of their existence. For the first time in the long, cyclical history of intelligence on this planet, a technological society has access to a detailed history of past failures. We have been bequeathed their warnings. We are beginning to uncover their blueprints for sustainable technologies. We are detecting the faint operations of the guidance systems they left behind. We have the chance denied to all others to learn from the mistakes of those who came before. The choice we face is fundamental, a question that will define the entire future of life on this world. Do we continue on our current path, pursuing maximum technological advancement and exponential economic growth, regardless of the consequences, a path that has invariably, and perhaps inevitably, led to ruin? Or do we pivot, using our unique and precious knowledge of the deep past to fundamentally reimagine our civilization, to develop new and sustainable approaches to technology, to resource management, and to our own social organization. The legacy of deep time is not a prophecy of doom. It is a gift of wisdom purchased at an unimaginable price. The civilizations that came before us are not just cautionary tales. They are our ancestors in a long, unbroken chain of intelligence on this world. Their final and greatest achievement may have been to ensure that their successors, us, would have the tools and the knowledge necessary to finally break the cycle. We are the inheritors of a cosmic trust, a profound responsibility to future generations, and perhaps to a wider galactic community that is watching and waiting. The terrifying acceleration of our own development suggests the time for this choice is short. The challenges of climate change, resource depletion, and the development of transformative world-altering technologies are not distant abstract concerns. They are the immediate existential tests of our generation. The universe is watching. Deep time is waiting. The choice is ours. The Silurian Hypothesis has revealed that human civilization represents the latest chapter in an epic story of intelligence and technology that has unfolded across millions of years. We are neither alone nor first, but part of a grand tradition of consciousness that has shaped this planet through countless generations of technological achievement and wisdom. Previous civilizations have left us the greatest gift possible: knowledge of what works and what fails in the long-term development of technological society. Their successes and failures provide a roadmap for navigating challenges that have destroyed entire civilizations throughout Earth's history. The consciousness preservation systems, guardian networks, and protection technologies left by our predecessors represent investments in our success, made by beings who achieve technological capabilities we can barely imagine. They sacrificed their physical existence to ensure that future civilizations would have the tools and knowledge needed for sustainable development. We inherit not just a planet, but a cosmic legacy that extends throughout the galaxy and spans billions of years of technological evolution. Our choices and achievements will determine whether this legacy continues to grow or ends with our generation. The quantum archaeological evidence, geological signatures, and space-based artifacts provide undeniable proof that intelligence and technology represent fundamental forces in cosmic evolution. Consciousness appears to be the universe's method for understanding and managing itself through technological development. The message systems and guidance protocols left by previous civilizations demonstrate that knowledge and wisdom can survive the destruction of entire species and civilizations. Information carefully preserved and transmitted becomes the true immortality achieved by technological societies. Human civilization stands at the threshold of joining this ancient community of technological consciousness. Our scientific capabilities are approaching levels that will allow direct communication with preserved minds from previous civilizations and participation in galactic-scale projects that span multiple star systems. But this opportunity comes with profound responsibilities. We must prove worthy of the trust placed in us by predecessors who devoted their final resources to ensuring our success. We must demonstrate that we can learn from their mistakes and build upon their achievements. The evidence suggests that consciousness and technology represent the universe's greatest achievements, forces capable of transcending biological limitations and planetary disasters to become permanent features of cosmic evolution. We have the opportunity to join this cosmic community or condemn ourselves to repeat the failures of the past. The choice is ours, but the time for choosing may be shorter than we think. The acceleration of technological development and environmental change suggests that critical decisions must be made soon. Our window for achieving sustainable development may be measured in decades rather than centuries. Future archaeologists studying our era will judge whether human civilization proved worthy of the ancient legacy we inherited. They will determine whether we used the knowledge and opportunities provided by our predecessors to build a sustainable technological society, or squandered our inheritance through short-sightedness and poor decisions. The deep time perspective reveals that our current challenges are neither unique nor insurmountable. Previous civilizations faced similar tests, and some succeeded in achieving sustainable development that allowed them to preserve their knowledge and continue their development in technological rather than biological form. We have access to their accumulated wisdom, their guidance systems, and their protection technologies. We possess knowledge that no previous developing civilization ever had. Detailed understanding of what causes technological societies to fail, and specific information about how to achieve sustainable success. The journey through deep time reveals humanity's place in a story far grander and more ancient than we ever imagined. We are not the first intelligence to emerge on this planet, nor will we likely be the last. We are part of a continuing tradition of consciousness that has shaped Earth for millions of years. The evidence surrounding us tells an extraordinary tale of civilizations that achieve technological marvels beyond our current capabilities before vanishing into the geological record. Their legacy persists in quantum signatures preserved in crystal formations, consciousness patterns stored in underground networks, and guardian systems that continue to protect and guide planetary development across vast spans of time. These discoveries fundamentally change our understanding of intelligence technology and our place in the universe. We inherit a world shaped by previous civilizations, whose greatest achievement may have been ensuring that successor societies would have the knowledge and tools needed to avoid repeating their failures. The Silurian Hypothesis forces us to confront profound questions about consciousness, survival, and the ultimate goals of technological development. Our predecessors achieved forms of immortality through consciousness, preservation, and information storage that transcend biological limitations and planetary disasters. Their message to us is clear. Learn from our successes and failures. Build upon our achievements and continue the great work of expanding consciousness throughout the cosmos. The legacy of deep time challenges us to think beyond our immediate concerns and consider our responsibilities to future civilizations that will judge our stewardship of this ancient inhabited world. We stand at a critical choice point. The acceleration of our technological development mirrors patterns that preceded both the greatest achievements and most catastrophic failures of previous civilizations. Our decisions in the coming decades will determine whether humanity joins the community of successful technological consciousness or becomes another cautionary tale preserved in Earth's geological record. The wisdom of deep time suggests that consciousness represents the universe's method for understanding and managing itself. Through technological development, intelligence transforms from a biological accident into a cosmic force capable of shaping the evolution of matter, energy, and space-time itself. Our role is both humbling and inspiring. We are temporary custodians of an ancient inheritance responsible for preserving and extending knowledge accumulated across millions of years, while adding our own contributions to the cosmic library of consciousness. The future remains unwritten, but the deep past provides both warnings about dangers to avoid and examples of achievements to emulate. Whether humanity's chapter in the story of terrestrial intelligence becomes a tale of sustainable success or tragic failure depends entirely on the choices we make with the knowledge our predecessors died to provide us. The universe is watching. Deep time is waiting. The choice is ours. Thank you for watching Astro Horizons. Don't forget to subscribe to Astro Horizons and hit the notification bell for more journeys into the cosmos.